Hello everybody out there, this is Shawn Mitchell with Paragon Films and I am here with Ben Dressler. Ben Dressler is with BGR and we are here at their lovely automation center in Westchester, Ohio. Today we're going to be talking about hand film and particularly hand wrapping applications and some of the things we see that are done incorrectly out in the field today. So we're just going to do a quick couple-minute tutorial and teach you guys the proper techniques for wrapping with hand film and how to get a nice, tightly secured load with as much consistency as possible. We're going to address some of those things that we see done incorrectly when we're out in the field auditing film with customers. All right, so the first thing we want to address here is when we're talking about proper wrapping technique, there's a few things we want to take note of when we're looking at Ben here and how he's actually wrapping this load. So we've got the film hanging off the back side of the roll, so it's coming up against the load and making contact with the load first, and it's not contacting Ben's body as he wraps the pallet. Second, we'll see that Ben's inside arm is on the top of the roll, and his outside arm is on the bottom of the roll. We're wrapping this load counterclockwise. So as Ben comes around the load, he's snugging the film up, locking it out on the corner, and then releasing the film to unwind. So snug, lock, release, snug, lock, release. And using this method, we're going to get much more consistent containment across that load. We're also going to get a lot less in the way of film breaks because we're not putting undue tension on that film as it's unwinding. So now Ben has wrapped this load and we've counted the number of revolutions that he did so we can use that as a baseline for our testing. So Ben put 10 revolutions of film on this load, and what we can do when we're testing in front of a customer in terms of hand film is we can take a baseline that we see going on in their facility as their workers are wrapping loads and say, okay, we see the worker over here is averaging 10 wraps per pallet with the hand film that you're currently using. So let's take 10 wraps as our baseline and let's wrap the load 10 revolutions with the current film, and then we're going to take a series of measurements and then let's wrap the load with 10 revolutions with the film that we're proposing, and we're going to take that same series of measurements, and that's going to give us a standardized way to collect data and then compare the two films from a performance and a cost standpoint. So we know standardization with hand film is extremely difficult, and Ben, I think you have experience with this, but not all of us can be machines.
Yeah, so in certain situations and in certain operations, a machine isn't going to fit the mold. You're going to have a lot of people hand wrapping skids. And so you want to set a standard for that. You don't want your standard to just be, oh, that looks good. You want your standard to be as good as a machine can do. So what we do with the science behind hand wrapping is we want to set a standard just like it's a machine. How many revolutions, how much tension, top wraps, bottom wraps, how much overlap you have in the middle. And we want to get all those things dialed in when there's a human wrapping.
All right, so once we have our load wrapped and we've used that established baseline of 10 revolutions or whatever that baseline may be that we're going to use on both the incumbent film and the film that we're proposing, we're going to start taking our containment force measurements. So Ben is using a torsion tool or a two-finger tool to take containment force, which is measured in pounds, and he's taking that measurement on the top, middle, and bottom of our load on the long side of the load. And he's actually going to take those 3 measurements on both long sides of the load, so we end up with a total of 6 containment measurements that we can then average together. And the reason we do this is so we can identify any anomalies in our readings and we can get a really concrete idea of what sort of force is being applied across the entirety of that load. After we've collected our containment numbers and recorded the data, the next step in the film analysis is going to be what is commonly referred to as a cut and weigh. This is where we cut the film off the load, take a weight, and record it, and then we'll later use that information for our cost analysis and overall usage analysis. The two key takeaways here are that we need to be educating our customers on how to properly wrap loads when it comes to hand film, and we need to be using standardized testing methods so we can perform an analysis when we're testing hand film in the same way that we would if we were testing machine film. This is the way we show better value to our customers. There are so many topics to cover when it comes to stretch film and equipment. I want to thank Ben Dressler and BGR once again for allowing us to come into the Automation Center. And this is Shawn Mitchell reminding you that stretch film never sleeps.